I think we can get started. We won't. Doesn't make sense to wait any longer. So welcome all of you. My name is Piyush Kataria. I'm acting as a architect in our company Red Panda Innovation Labs. Uh, sorry. Okay. Is it because that? Or, okay. Okay. Yeah. So. Um, How many of you have gone through the previous sessions? Because this is going to be a third session. You already took two sessions about JavaScript, ES6, Lambda.js, and how to, kind of think in a functional manner. So, have you went through this? Okay, so, and how many of you use the JavaScript at the workplace? All of you. Okay, cool. So this talk gonna be relatively shorter, where I talk about how to think of coming up with an architecture, because it is a very convoluted term like architecture, and there are many flavors of it, and we'll just discuss uh, which one to go for, what are the different things matter, what are the basic, criteria we should look for. So, and this is going to be, instead of me only driving it, I like it to be a discussion. So, the best time to comment on any of the topic or ask a question is when you have in your mind. I might have to delay any question which I found little out of context until the end of the session, but otherwise we are, can have a healthy discussion about anything which we are going through. Okay. Okay. So before I start, I just like to ask, casually, what's our understanding of architecture and design, and how they are related? Do they complement each other? Do they oppose each other? Are they completely different? Is the What kind of context does matter? If they complement each other, what kind of context does not matter if they oppose each other? What's the architecture? I mean, what comes to your mind? Skeleton of application. Okay, is it really a skeleton? Hmm. So how is it different than design then? No inputs. Okay, so let the authority jump in. Okay, so there is a very good article which was published by Martin Fowler, Who Needs an Architect? Okay, in that he mentioned that the two different definition of the architecture. One architecture, as we see in the most company, typically they follow waterfall architecture. Sorry, waterfall processes or legacy thing is architecture is something which you decide at the start of the project, and you just abide by that. Okay, and that's something you know doesn't sound a very agile definition of it, so he goes on redefining it in a different way. And he says that the architecture is nothing but a shared understanding among all the team members who are working on that project to realize the components of the, at the high level, how the component of the system and how they interact with each other. Okay, so still, like, then how do you differentiate between an architecture and design then? So well, we could say that the architecture, I'm just setting a space so that we all are on the same page, but you don't have to agree with me. You can share your opinion. So architecture is as Wikipedia defines it, the intellectually graspable view of the system. Okay, it might tell you what to do at the very high level, where to do, but not how to do. The how to do is defined by the design. Okay. Um, so this is the architect. This is the definition. Now let's consider to work out through this definition, share understanding amongst at least the people in the session. Uh, let's talk about building a very simple application, and you know, um, let's start with very trivial language like PHP or maybe JSP. Okay. So what I have is I like to build an application, a web application simply, right, where I do each and every URL respond with some HTML messages, right? So what do I have? In a typical LAN stack or a JSP, um, I have the whole code in my one file. So there is one-to-one association between a URL and the actual JSP or a PHP file. Okay, just that. There is nothing else. Okay, you start with that. You write suppose you, for example, you are using RDBMS or any other database, but you are directly querying it, right? In that file. So what's wrong with this architecture? So I mentioned three things. There is one-to-one association between a URL and the response get by the HTTP server. Your all logic in a single file. So number of files in your project are directly number of endpoints you have. Okay, you write the SQL query there, you produce the HTML output, do whatever you want to do. Even if it's a post request, you always do the execution of business logic in the PHP or JSP. So what's the problem with that? Do we see any problem? The first thing is it going to work? It's definitely going to work because there are many of the PHP sites, and the sites old fashioned, they have done this way. Okay. And we say that when we make the decision about architecture or the design, there is nothing right or wrong, there is only better or worse. So what is worse with this design? Right. So okay. So the first step is to have a reusable code. Okay. So what I did was, as a first step, um, just have a different view and the functions. Right. That's the first step we can do. So against each and every endpoint, there is a view, PHP or a JSP view, right? Or any other templating engine, which only does showing, the show part. And it does not make the query, database query or any other third party calls in the file itself, but it makes use of the different functions which are defined maybe in a common file which other views can also make use of. Okay? So what we did here, we added one other level of indirection, right? Do not refer it through the reusable functions. You may wanna call it like business, like business.php or business.java, whatever it is. So So views are different, and there is one God file which has all the business logic. That is the first step at least we can do, right? Okay, so what did we achieve here? The reusability of the all functions. I don't have to depend upon it. Is it still better? Or we can do more better than that? By the way, we are able to imagine what's going on, right? What, what's the next step? So we have two layers. Okay, let me introduce. So far we talked about only generating the response. So let me create a new requirement that site needs an authorization, right? So not all of the views or pages are directly accessible. You have to go through the you have to log in into the system. So if I implement login or authentication or authorization, what changes I would make in this design? We are doing incrementally, right? Okay. And we also have a shared understanding because we are discussing it. So what extra layer would you add? Right now we have two layers like view or maybe you say model. Model in the sense that the business, don't say model, okay, only the business thing, directly the business thing, which does not distinguish or does not have a very, good abstraction over the database. It just manipulates the database and all very locally in its methods. So I like to have a login. So is it sufficient? So I have a login page. I go to that, and so let's try to implement in this two layers, the views and all. So, hey, hello. We just started, yeah. So there is only so in my application there is only one view file, PHP or JSP file, which is publicly accessible and which is like login.jsp or PHP, and rest all of them needs authentication, right? So what I do is I go to every other those 100 files other than this and write the code and say what? Check whether maybe in terms of cookies or headers, the request I get, um, is there anything like, uh, is that person authenticated or not? Maybe I could define only one function in business, the business file and have it. But then you have to, reflect on all other files and so many duplication, right? So how to avoid that? Can't we think of any layer which comes before the view, before generating the response? Would it be helpful?
In-building check which can redirect to files.
Okay, a layer before the view. Okay, let's call it as, I don't know, interceptor, right? Router or maybe interceptor, and which checks for the validity of the request, right? Whether it's uh, authenticated or not. Okay, so we have three layers now: the interceptors and the the actual view it redirects to, and the business logic, right? Okay. Um, so far so good. Now I have another requirement. By the way, what we are doing here is adding another level of, indirection, because having the layer. So it's trying to introduce two major, concepts which really matters. Okay. As I said, I'm not going to talk about any of the predefined architecture, but what are the different things which matters from which all of the architecture has been evolved. The only architecture I'm going to talk about specifically is domain-driven design. It's going to be short later, but these are the two things which really matters. Abstraction help you achieve to manage the complexity of your project, your different layers, and indirection help you achieve what? Indirection help you achieve what? The transparency between the two different models. So as the definition goes, indirection is the ability to reference something using a name, reference, or container instead of a value itself. So in a very crude sense, like for example, lower level languages like C, C++, have the not C++, but only C, like have directly access to a pointer or a location in a memory. Little higher level languages like C++ or the Java avoid that by having the handle given by the objects, by creating in the objects. So that is indirection. And indirection is not abstraction. These are two different things. Abstraction is about, managing the complexity, only focusing on what you want, and and of course when you're doing abstraction you are encapsulating something which you because if you abstraction is all about making the complex design simpler, it has to hide the complexity. Okay, so back to our problem. I have an interceptor, I have a reaction views, I have a very one God business, jar, one file which does all the things. Okay. Now I like to add. Um, I have a requirement where data. I like to change the database. I went with maybe MySQL, but my client says that I like to use the Oracle for the production use. How do I do that now? Or maybe there are some use cases where I might choose totally different database to process the data, you know, because of the data growth factor itself. So what should I do in my current design then?
You said that the data model, how it's represented in database, something like that. Your data as a certain model, and the data fields, you have an interface with it.
Right. So I will split the business into two. One is only actually executing the logic, and one is many people call us the repository layer. So behind the repository layer, you hide the complexity that are you accessing RDBMS or NoSQL or any other kind of database. Okay, so we evolved from only one layer architecture, one layer design maybe, to the four layer. We have a all shared understanding, right? So now I want everything to be testable also. What should I do? So current architecture looks like this, like interceptors, very bunch of views, which are total number of views or PSP file are equal to the endpoints we have, right? And we like have our two files now, right? The business and the repository. But I like to make it testable. Is it possible? All kind of testing. Right. So, what different things should I make use of? Sorry, what different changes I should, go for in the current design? So, current design is interceptor. There are views. The redirection of views is taken by interceptor or maybe router, whatever pattern, and views call the different business methods directly, right? And you have a repository. The business layer is a service layer. Okay, but there are only two files. One is business, one is repository, because we are going increment in an incremental sense. So maybe we can. The first step, simple step is instead of referencing repository directly from the business, we can instantiate it, maybe module wise, so that we can inject the mocks. Okay, and
You can do it hardcore within the business line that provided.
exactly, yeah, yeah. So we are going incrementally. In the last design, we are hard coding it. So now we will pass through the injector, okay, so that I can mock it. Okay. Now I have another requirement. So there is this 3 to 4 endpoints which get called very frequently, and it kind of makes 60 to 80% of my traffic. Okay, so those directly points to maybe 5 to 6 function in my business file, which I'm directly calling from the the view. Okay, I like to do an optimization on it. What should I do? What kind of optimization we can think of? Because each and every time it does get called, it does make several call to the database. Caching, okay, caching, but what kind of caching? Where cache would you have it? Please ask me a question if you're not able to imagine, like, how it's going and if I'm not. Caching is a fair idea. I mean, it's fine if I cache the value for, let's say, one day, it's fine. And the data doesn't change really frequently. So 24 hours is fine. So, okay, caching. So what changes should I make in my design? Should I introduce another layer which kind of does the caching and does not call the business logic directly from it, or and have the view call that layer? How is it going to be? Or should I maybe change the way we are generating the response and the data is getting filled into the view? How is it? By the way, you are open to think anything, like, if you want to bring any library, any database, let's talk through this out.
It's like in NodeJS we have some event loop concept and we use
An event loop for caching.
not for caching.
Huh.
Because we are directly hitting, right?
Okay.
Whatever the pending events we keep into the loop and then once they are completed, we get it back.
That is to save the response in caching value, or I didn't understand the purpose of it.
So I mean to say is, for example, if we are hitting the block right?
Yeah,
Or
yeah.
same inform,
Mhm.
if that is taking a lot of time,
Hmm.
right? So just pass that because we will compute, we will do meanwhile we can proceed with different ways.
But that is optimizing the code. But I don't want to. So okay, let me make them more explicit that the as I said, data is not going to change, and we can assume that in a 24 hours, or at least 24 hours. So what the caching is a fair idea, but where should I implement it? While generating a response in the interceptor, by having another layer before the business logic, by having the caching layer at the repository level, where actually?
You think of like client side or server side?
This is all server side. Yeah, the client side also we can do. That is one fair point, that you can have a meta tag in HTML that this response is gonna have, but that would work only when a particular customer is accessing that page twice. So that cache is only for that customer, not across all the customers which are accessing our site, right? Yes, but yeah. So that is one fair point. For at least for customer, we can implement the meta tags and cache in the HTML file. How to take care of the different users which are kind of making the same calls, which returns the same input, return the same output response for a given day, and it doesn't change. So at least we can agree we need to implement the cache. Okay. So okay. So let's. So where do we want to implement it? Let's start from the repository level. Okay. What are the implication if we only have at the repository level? All of the business function which are using that repository function will see the cached value. Right? Yeah, but is it really specific to that view? Maybe not. Okay, view might be accessing different attributes than what is being cached. Okay, so it might be accessing a value from 3 to 4 tables, and some of the attributes it, but there are some of the attributes which get changed, and we do not guarantee uh, that it may or may not change. Okay, so at least for solving this problem, the caching of the repository will not be a good idea. Okay, let's move one step here. Let's introduce uh, the actual layer before the business layer, which does the caching. Okay. So caching is just the function memoization kind of thing. Like you look at the inputs, you make an object out of it. That's actually you make a hash of it. That is your key, and the response you get is the thing. Okay. Um, so yeah, it seems to be a fair idea than actually implementing at the repository level, right? Okay. So what you actually caching here is uh, the response. So you are avoiding the calls to the database. Okay. And you are still generating the response. It is going through that. It is still there is a whole bunch of large string, and you still have to process it. Okay. Um, so okay, what if we implement uh, at the interceptor level or the router level? So instead of so this is time to rethink about whether we should directly call a business method from the view, or we should directly pass the data to the view, the template pattern, the suicide template pattern, right? So what are the advantages and disadvantages? You have a very high coupling between the view and the and view might not, if you're using compiled langages and if you like to make use of that, um, it may not help you. Or so what if in the router I compute the data and just only pass the data to the view and treat the view as a template and generate the output. Sami, can you accept if someone has joined?
Yes, Piyush, will do.
Okay, thanks. So what's because I wanted to have this exercise to to bring the trade-offs that it's not always the indirection matters or abstraction matters. It's only about the decision how you take it. So what are the advantages if I directly reference a call to a particular thing from the your PHP or JSP file or having the template? Sorry, sorry. Yeah, yeah. So what I'm talking. Okay, let me. So previously, what we were doing, like, have the view call that particular function. So it is in that view file you are calling it by importing or something like that. Is it really helpful? So when you take that function out of the business call out of the template, you have a flexibility to replace your template engine first, right? And you do not have a code dependency like uh, so the complexity comes when you have a dependency, right? And it's very hard to manage. And plus, if you have a several layers, right? I could, since I have implemented right now the caching at the business layer, okay, I can get it, maybe do some transformation or maybe look for its timestamp value, whether it's valid or not, and then make a decision in the router whether to make the use of cache value or maybe produce new one. Okay. Um, so those are the flexibility you would achieve. Now, what if I implement the caching at the view level itself? Because what is being get cached is the only the data value. It is of course dividing the it is avoiding the database call. But what if I implement at the view level? And by the way, you you can think of any distributed hash, maybe Redis or maybe file system where I'm making use of, the number of inputs is the key and the data which I return back is the response. There is this hash table, and when I, on a given day, a simple logic, when I request for it, checks the timestamp value and return the response back. Otherwise, it lets that call pass through to generate the actual value from the database. Okay. So what if I do at the view level? I don't have to compute, I don't have to spend my CPU cycles in generating the output, generating the templating engine, whatever it is. I can, generate it, maybe gzip it, the whole thing into the memory and just have it. It's going to be definitely faster than that, right? Okay, so this is how to think about various things. Okay, now in terms of repository, similarly, if I want to have only one database and if I like to uh, debug it or maybe test it, debug, test, or uh, have the different database connections, what should I do is, instead of hard coding the actual DB connection into the repository, the DB service is different, and then you inject that. So we evolved from first single layer to the various layers depending upon our shared understanding of growing complexity, right? Yeah. And this level of indirections, when you do it, brings some benefits also at the trade-off. Because now if you like to change it, you have to look for all the things. It is being cached, is it being, uh, executed, what kind of database it is going to, is it making a transaction and so on. So most of the problems, I would not say all the problems, but most of the problems are solved by indirection, except the problem of too many layers of indirection. So do you see that diagram? Okay. So some of things we already discussed, like intercepting filter and having a router of a controller and then having this thing. Okay, so this was the J2E design pattern. People like Java and being the kingdom of nouns, they really like to focus and convert each and every requirement into the layers. This may or may not help you. As I said, like the more layers you bring in, the more complexity you have, because you have more. You have to think about every other layer and the individual cohesive responsibility of it. Okay, so this was the architecture which I followed when I was in Vodafone India, and it took me like 2 months to understand the whole project. How is it going? There were several modules. There were, of course, no test cases. So, and the way it is done, like so intercepting filter is for interceptors. Front controller is like I take care of all the requests and then I will have responsibility to redirect to it. Then you have a service worker, business delegate. From each and every one, when you pass to the object, you give it a name. Is it the view object? Is it the transfer object? Is it what kind of object it is? And these are like composite entities and service activator pattern using EJBs and whatnot. Okay. And so the thing is, while you achieve the very flexibility into the different layers by adding more layers, you also add the complexity into the system. So that is the trade-off you always have to be aware of. Okay, so it's done. Like I did created monolith and this thing, and right now I have to use microservices because my manager said so. It's the latest technology, latest concept, and everybody talking about it, and because it is only the microservices will scale. It's not the code. It's not nothing because only the microservices can scale. So, how many of us have heard of microservices? Have you actually implemented it? How many of us have actually implemented it? Okay. So, sure. Um, so there are two things which matters. Like most of the thing when they mean like scale, they do not. They definitely are not very specific about scaling what exactly they want to scale. And most of the time, what they mean is they want to scale the relationship with customer because customer is easily convincible because it's microservices. Okay, any of you like to share your experience? Maybe Douglas, you can share experience.
So in the project I'm working on, microservices helps in one sense is that it's a very large project, it's a very large platform, and it's divided into several teams. So there are about maybe 15 teams, and each team owns its own set of microservices that they interact with the services on their teams. So in that sense, it's helpful because the division of work is easier because the responsibility is easier.
Okay.
The teams that there's like a huge operations overhead.
Okay.
So we need to make sure that when you deploy a service or anything, and you change all dependent services need to test with that chain.
Yeah.
Go live together. You need to if the interface is changing between services.
Yeah.
Then you need to inform the other services. Exactly. So there is that overhead, but you get certain advantages. And I think if it's a very large platform, then maybe it makes sense for like simple applications with overheads with
Okay, sure. Any of you want to share experience with microservices? No? Okay, we'll come to that. So, all the things we discussed, right? And so these are the major driving factors which matters. So, uh, I like to focus on what Ken Beck said. Ken Beck is the guy behind the TDD, the marketing of TDD, making it work across the whole of the communities, different kinds of communities. And he says that um, optimism is an occupational hazard of programming. I think it's not only programming; it's most of the time in social life also, and feedback is the treatment. So, since architecture depends upon design depends upon the code depends upon how you really will test it. This is applicable for all the layers. Okay, so these are the things you should at the high level take care of, like initial market research for given business domain. So I like to have an e-commerce project, so that there are already many of them. So it always helps instead of going and um, learning by mistakes as we learned, like in the previous example, like we introduced the layers, several layers, one by as we found useful. It always helps if someone already built it. They might not have built it using or having the enough layers, but you can at least get the idea that what really goes on, what are the different modules, what kind of interaction you want, what kind of loose coupling you will be, wanting to do. Second is the security, as we discussed, like authentication, authorization, and how does that matter in your architecture. Transaction capabilities and boundaries, or making the some kind of preserving the some kind of context within the request. Like for example, if I'm doing a transfer from one account to another account or similar cases, um, I am kind of dealing with number of tables in the data store, or maybe number of other systems spread out, and I like to maintain that context with all or nothing, consistency. Either it persists them all across all system, across all databases, tables, whatever it is, or nothing. Um, so this is normally achieved in the multi-thread application using having thread context. So wherever the thread goes, the thread variables also goes. Okay. Then online active users growth. Now most people do not understand, like if I want to have an e-commerce site, they will only focus on creating it as big as Alibaba or Flipkart from day one, because that's not the fair thing to do. Okay, because number of users you have are never equal to the active users, and number of active users are not equal to the actual incoming request, right? So these are three different factors. Of course, the data growth. What kind of data growth you will incur in your application? Okay, is it only so it really depends upon the business domain. Suppose you are creating an analytics engine. Okay, the data tuple or the record may not have a much value, but the count of it's like the billions. In other words, like e-commerce or any other project, CRM projects, you have many attributes, okay, but may not be that much of a data. So it really depends upon, and the more you can think of, the more feedback you get from, as I said, in the market or the given business problem you're trying to implement. You may wanna uh, decide which kind of data store you would go to. Is it has to be transactional? Then maybe RDBMS is okay. It doesn't have to be transactional, and if you can bear the eventual consistency, you may go with something like Cassandra. If you have a very frequent requirement, mixed kind of requirement, where you have a very changing attributes, a very different kind of queries, and you also have a fair amount of load. So you may go with MongoDB in that case, and so on and so forth. Testability is important because it just shortens the feedback loop. Because everybody wants, fastest time to market, fastest time to market. If you do not make it modular and testable, then there's no point of, I mean, there will be more frustration each and every time when you release it. Um, and there are some integration points like SMS services, email, different in microservice architecture. If you really like to go for it, uh, your context map or transaction spread across different system and so on, so that should be also taken care of. And response generation eagerness is about, is it real time, soft real time, hard real time? Can it be made async? Okay, and rethinking and revisiting these ideas to is that response really needed for user? Because and the last point is the response generation eagerness is going to change your architecture very much than any other thing. The amount of change it brings is going to be huge than other factors, because then you have to think about every other module having to wait for it. And, it's always good idea to go for a default, because even if you take an example like in a normal sense, in a daily life, I don't want to walk through all the events which I am going to, or all the meetings by looking at the calendar. I want calendar to remind me. Okay, so if you follow the async approach and only when it is needed, it will make the little complexity in your system, but it will be more useful for the user. Okay, any questions so far? Okay, and so so this is the default architecture. Decisions you have to make at the higher level, and then the way I find microservices, which I have done like 4 to 5 years back, um, my experience was that it has to be, it was more social than the technical, because when you say technical, it is always a possibility of can we do it, and the answer is always yes. You can have enough indirection, maybe using inversion of control to start with, to start with, and you could use even for the performance or any other level, you could achieve it in the monolith. Okay, but there are some factors which matters. So these are, so when we scale, there are three different things which comes to my mind at least. Is like scaling a few business use cases. Like for example, I started with the business, and there is suddenly a new requirement that I have to do very computational image manipulation and what. But I was using some language like Perl or Python, which does not have a very good capability or doesn't have any library for image manipulation. And but there are some, so I might have to um, extract that functionality out into the different system which is built using C, C++, or any other language which is any other language or a platform which is very good at doing that computational job of image processing or any other thing. And and so I can scale that particular business use case. Okay, it could be that sending SMS, emails, and looking for it, whether it's send or not send, uh, looking for the feedback from the gateways and stuff like that. Scaling the whole business module. So if I'm launching the e-commerce site, what are the different section I should look for? Like the addition of the product management, the actual site, and the payment management, and all such a stuff. Okay, so if I divide into that, I can individually focus. Okay, so the more number of requests will always come from the actual website. Okay, because it is being, those endpoints being consumed by your Android phones, iOS phones, the web browsers, the images, and all. I might have to have a very different set of infrastructure for payment gateways, because such a, at that level, if you go, there are frequently audits, like how is your system, and to get approval of something or at a standard level, you may not have to maintain that infrastructure level at each and every modules. So you have a completely different provision how the payment gateway work and what is the security mechanism and all such things. Um, and of course, there is a huge chance, because you are able to split the business module into a different section. You can always make it as a software as a service, right? So you started with the internal product, but you made it more modular, such that it may not have to depend or direct dependency on another module, everything through the interfaces, and that's why you can scale across for other users also and make money out of it. And the most important which I have seen is scaling a team. Okay, and so because of the open source culture and open-minded culture, I would say there are very many developers, there are very many um, the leads and architects, they come from a different background and they have their own biases about the programming platform they use, the business domain knowledge they bring in, okay, and they may not want to, always participate in other modules, okay. This, by the way, also helps in, when I mean scaling a team is like having in a different scrum together, so that I don't have to bother about what different business module is caring about. I bring in my expertise, this is my job, and I like to only focus on this meeting, the very specification of the very cohesive problem which I'm trying to solve. So, and the maintenance, because maintenance is always going to be the problem. Not problem, is going to be the relatively high effort when you go for microservices, and because difference because of the biases of the platform expertise, programming expertise, there are different ways to maybe profile your environment, maintain your environment, make analytics out of it, and things like that. Uh, and one more point is, whenever you have a microservice architecture, it do not depend upon having uh, like a DNS names, or maybe in terms of if you go for AWS, the Elastic IP, have it through the distributed message queue. Because what matters is, uh, um, so when you have microservice architecture, whenever you, as pure angle from the user, you are making a one request, but it is actually causing the several calls between the different systems to make that happen. And if it's not persistable, it's not debuggable by the operation team. Okay, so it's always good idea to have it persistent storage and have it async flow public subscribing model in order to have that request completed. Okay, any questions? Okay, now so far the different layer architectures and all we discussed was only based upon our requirement, a technical requirement. So the domain-driven design says enough about the technical requirements and all. You should more focus upon building your so domain-driven design says, like, if what do you say, the DSL, domain specific language, is the ultimate abstraction, because unless you have it, you will not be satisfied. No matter how many layers you have and what doesn't for solving a given purpose or problem. And there is this technical requirement. Okay, so you can come up with something called as ubiquitous language. Okay, which has a more focus being driven by business, but also has a very good share of accepting the technical difficulties. And as ubiquitous language, as you can see in the image, it's not only about the developers, also about domain experts, analysts, every other thing. Okay, and to bring in this domain-driven design, the way you would redesign the architecture or the different design layers which we discuss is by only focusing on the domain first. So suppose you receive some of the request, okay, which is nothing but I don't know, value object here, a request object. You might write it. Even if you do something else, you have to convert into a business object. How does that how do I recognize that object into a business? How does that object fits into my domain? Then you create a business object out of it, and you write the whole business logic, and it's very separatable. Like you can always separate. So in domain-driven design, there is a fair amount of decoupling between the actual business logic and the persistent logic, or the STP logic, or sending any other basically any other infrastructure service calls. Okay. So if I so we achieve the coupling between the business and the domain and the infrastructure. Okay, so request comes, you convert into a business object, you perform an action on it, and the whole context you are maintaining is from the business angle. Okay, and then you have adapter layers to get it persisted into the different data stores and or the services. Okay, so this kind of design may not be useful for all of the projects. You might have to decide like how complex is the domain, because it needs very tighter feedback loop from all of these guys. And if you're not able to achieve it, you may not be able to appreciate your design, and it's like very complex. Like I could have done that, instead of forwarding the call to the whole business module and doing it, I could have just done directly through making a database call or repository call. These are the different components which matters. I will not talk more about that because it might gonna take the whole session. But I can point out some of the things like the value objects are always immutable. It's something like so entities are the actual domain entities which matters. Entities may or may not map to the actual persistent object. Okay, and aggregate of entities. So we talked about having here the transaction capability and boundaries, right? The context boundaries. So that is something achieved using entity and aggregates. So suppose I am doing a certain transaction in an e-commerce site, maybe having a user, right? A given product and the payment gateway. Okay. So all of these things, before I make a transaction and the request comes to me, in the entity, in the aggregate object, I would fetch all of them. Okay, and then make a decision that what should be done. And until that point, until that request context, nobody should be able to touch those, that data at the data store level. So maintaining the transaction. If you're already maintaining it through the payment gateway, it will also involve other services also. So that brings in another complexity. And there are various ways to achieve that. One of the way is like just having the optimistic lock, which is not very scalable. The another way of having like something called as CQRS pattern, command query segregation, where you segregate your reads from writes, and you depend upon it. Yeah, I mean it's okay, it might happen, but I need scalability, and it is okay to have an eventual consistency. So if two requests comes in, that's like $1 million question for every interview. Like the selling point for the databases, like it maintains the ACID and all. Well, that's fine, but do you really need it? Or can you focus more upon having the infrastructure where eventual consistency can be reduced to a few milliseconds? If you could do it, then nothing like that. Services are normal. Services takes care of The external services, email, the other calls to microservices, if you will, and very local services also like file systems and any other thing. And all of these, like entities, value objects, and so value objects are nothing but the variable which because you have a separate domain model and different persistent model, very small amount of it. The the object which you pass to call different layers around it may not have may not have to be a domain object. So in that case, it's a value object, and it just it's not supposed to be mutated because it was just like a request object. You cannot override because the intention of it came from the user. Okay, and all of these things are instantiated by factories. So factories kind of a normal factory pattern, like which reduces the complexity of instantiating it. Okay. Yeah, I think this is pretty much okay for this session. Any questions here? Okay, so let's jump to the actual KoaJS framework, and let's see how could we implement those different layers which we talked about. Okay. So KoaJS is by the same authors which gave us the Express.js. It's the ES6 framework. As we have seen in previous videos, like if you want to achieve the continuation on promises, the core library is good. And so internally it uses core library to achieve the yielding of various different things. And it has a very modular architecture, like for example, Express 3.x. And in 4.x they made it little more modular, but KoaJS is very, when you install Koa, it's just a Koa core, a very simple wrapper over the HTTP, NodeJS HTTP API. So there are different like KoaJS views, KoaJS CSRF, KoaJS caching helpers, KoaJS maybe OAuth. So they have a modular structures and they have all different kinds of plugin in their community where you can kind of compose them when you actually build the application. And it is compatible with Node.js 4.x because that's the very stable release which actually supports the yield parameter, yield keyword. Okay. So this is the site Koa. It also supports async await function 7.6, but I would not recommend using it in production because this is not LTS version. And okay, so let's jump into the code. So these are the different things we use of like simpler components like Koa, body is for JSON and something. Compress is for gzipping, and router is simple routers. This is one of the project. Okay, so this is how you compose them together. You have a Koa, Koa compress, and you basically register those different configs and start at a given port. Okay. One thing which Koa does not provide is semantics for functional programming. Okay, so if I want to maybe I can go through some of the examples here. Context to better understand. No. Anyway, okay. So I had to build the wrapper over it to make it more functional. So what it does is, so as we're mentioning it here, like use Koa body, use router.routes and allowed methods and compress. So all of these methods return a function generator. Okay, and to that function generator, because we already have the function binding JavaScript, right? You can make call to a function by having the context set to a particular object. So whenever you use this into that, it will point to that, and that's not very user friendly when you do a functional programming. You want everything to be received as an input. Okay, so that's our effort to convert what is not there in the Koa to bring into the more functional way. So these are like simpler handlers we had to build in order to. Um, so this is the one, like this dot status. Every time you do a mutation. See, so at least if you cannot do a functional programming with this thing, you can reduce it to a particular handler which does the mutation. So this is sort of like a monad, if you, in a sense, which take care of the mutation part, and we are going to, so that we can wrap the handler. Okay, so everything starts from the routes. Okay, so we have a different modules all together here. Okay, so these are the different modules. Is it visible? These are different modules. Okay, and each and every module you have what we discussed earlier. Oops, oh sorry, this is the specs. Yeah, this is the one. The routers where you actually use where you actually register the functions, how and define the flow of that request in terms of what going to be the interceptor, if there are data validations, business validations, you mention it here. So this is like composing. So if this is the thing, compose all of these handlers. So these are composition of all the handlers. Okay, so this is the same library which we open sourced it, FN validator, based upon functions. You already have a schema, and now to convert this thing into the actual. So as I said, like what KoaJS accept is only the function generator. Okay, where you will get the parameter as the context of it, but not necessarily um, the argument to that function. The argument to that function is a function which you should get, which you should call in order to resume the request flow. Just like a servlet filter in Java or in the system. So we had to implement a simple validator here also. Like, so if this is the schema, then all of these things, and as I said, like, you have a very flexibility in Node.js module to expose what you want and how exactly you want. So all this schema we are transforming into the handler which takes care of this. So only if it is okay to go with it, yield the next or pass the control to the another handler. Otherwise, just set the records and just end the flow.
So what is the this in your it is the response object directly.
Yeah, yeah. So, okay, let me show you. So that is how it works. I mean, these are the people came from ExpressJS, so they did not, get over the fact that it should have been more functional. So what they do is, so there are various methods of, calling, making a function call. What? A slide. Yeah. So so this is what I wanted: direct invocation. Okay, because it. So they did not give me a direct invocation. So if you look at invocation pattern 3, apply, yeah, so this is the one. So instead of passing the null, they pass the actual value. So you call the array, or maybe this example would suffice. So you have an object, right? You have an increment method. But what if you do not have a value in that object? So you bind this value, this dot value at the runtime. So every other function generator which you have registered will get called internally by KoaJS with this different attribute, which will have like request object. Inside request you have a body, then parameters, headers, and response, status, and all of these such a things. And when request gets completed, it also look for some of the attributes like we have seen here, status and body directly, uh, and this is an indication that user want to persist into the network back to the user. So that's how you do it. Okay, so and router. So this is how you compose, or if you want like to compose even at the parent level, like check authorized user or something like that. That composition is also fair here. And of course there is handlers, which are nothing but actually, so it's simply the business logic. And because it more focuses on only on the technical, it may not have all the advantages of domain driven design, but it still work because I mean there are certain guidelines you can follow. Like, so for example here we are not making use of any rest convention, we are making use of RPC protocol. So all of the requests, whether it's a GET or all, everything has gone through the wrapper of RPC, which is a very simple wrapper which we have written. Okay, and we follow that convention that um, even if you have to take care of any CRUD operation, you do it with the post, okay, and you get the response back. So, and because our consumer is also a JavaScript in Angular, um, it feels like I am just uh, making the another method call, just like my method call and getting it.
These are all guidance services.
Yeah, yeah. and to solve the other problem, like having the different models, and we have simple. So one thing we discussed in the previous session was, because you are using dynamic languages and all, you should always take care about the boundaries. What exactly are you accepting, and even from which source you are accepting, you should put a restriction there. Okay, so this is the ODM, data mapper for MongoJS, uh, MongoDB, where you have a different schema and going on. And none of and what I really like to highlight here is this package known as the ESLint plugin FP. So it has a set of rules which forces you to not write the non-functional code. So if you try to do let or var, it will complain. Only thing which you can define is constant. Only thing you could do is transformation. You are not supposed to mutate anything, and to do a different uh, computations, we are using our same library, lambda.js. If you want to do, maybe I can give you example of this. Mm, where we are doing the actual, oh sorry, this is to come, manipulation. Yeah, so this is the one, like pick and filter and complement and all sort of stuff. Now the so because you are here, you are following the incremental architecture thing, it's also necessary to revisit this APIs and the kind of operation you are doing, and making extracting, sorry, extracting them into different business use cases. Like for example, uh, because of the very nature of this project and changing requirement, we do not know what's going to be reusable. So first go with that, and as in when you build more services and all, look at the existing endpoints and look for the common code. And because it's only the transformation doing uh, using functional programming, it is very easier to extract that code out if needed. And uh, I think I have the Jasmine going on, so maybe I can. Oops, maybe. I did not build the geo index of it, but if you could see, there are over 130 specs in 5 seconds. Okay, and at least most of them are making the database calls. Okay, so that's about that. Um, we also have a very strict. So ESLint gives you to control your um, the various conventions you follow, and this is very boon if you're not getting any help from compiler, because it's not statically typed languages. So it only focuses on the different activities. Like this is the FP plugin, like do not make use of this var class, not events, no deletes, no loops, only use map reduce. So it will tell you when you actually make the code and for loop, it will tell you that use some other functions, use map and something like that. No mutating assignments. And the most important, this may not be as relevant because security might is improved in the sys.x version of Node.js, but previously there were it was more prone to the buffers we use, right? HTTP buffers and all, the file buffers and all. They were very prone to make security errors. So if you write such a code, it will tell you that it's a bad code from the security point of view. And we follow some aesthetics like the indentation for, and we do not use semicolons and quotes and stuff like that. So it's always good to have, because you might have people which use different convention, different plugins using different IDEs, but it's good to have something in your build system which follows the same standard convention across all the. So that was about KoaJS and the build system. Any questions here, or if you like to know more stuff? Okay, so the last remaining point, I guess, is the deployment process manager. So Node.js already comes with the inbuilt load balancing module called as cluster module. Okay, and you can just write a simple script to spawn actually your server, but there are many of the things from operational point of view it does not support. Like what if I like to query the different uh, s- metrics, like how much CPU or process taking, how much logs they are maintaining, where it's maintaining, and what if the any exception cause the process to die, who would be there to restart it. So all of these things are taken care by a plugin called PM2. It's the very famous, it can be used not only for Node.js but also Python or Ruby projects. uh, so it has all of these things like starting, clustering, making the number of processes and stuff like that. So if we could quickly look at it, so if I have like PM, is it visible? Okay. So PM2, and I have to mention app.js. App.js is again, you know, so these are the different modules, right? You start from the persistent layer, MongoDB, the ODM thing. Okay, and by the way, one thing which I did not discuss was, even if it's a ODM, we are not making use of. So in ORM, ODM, or OGM, what you do is you mutate the value. Okay, so you get some value if you want to update by querying it, like find by ID, and you make a modification and then you persist and save it. So that is something which we disable for our case by having this thing, like don't do it. Okay, so it will always require you to call it explicitly. Why? Because tomorrow, if you like to extract that code, it is very easy to, kind of test it, memorize it, or scale it that way. And throughout you get the referential transparency, right? Every time you have have to do any changes, you should be explicit about it. Are you making a get query? Are you making an update query? Be explicit about it. Okay, so let's start the app.js, or maybe say uh, 4. Okay, 4 Python threads. Oops, sorry. Start app.js. So it started. Okay, so it will tell you what is the, you know so if you like to query, say pm2 list. Oh, sorry. So it's like, so uptime here was 0 second. It's a 22 seconds, right? And it also shows you the logs if they are printing it. Uh, so each process has its own log. Okay, so this is 0, 1, 2, 3, 4. What is being output? It's like, doing the tail of all those 4 logs, 4 different files, and printing it. Now streaming, I like to quit it. And there are a whole bunch of things like, and by the way, it also, so suppose I just close the MongoDB, and if I want to list it again, I wanted to crash it, but anyway, okay. So if it crashes, your the restart count get incremented. Okay, so you can also do like pm2 stop all. So everything is stopped. Yeah, reload all, stop all. By the way, stop all doesn't stop all of them, so you have to like delete all of them. And now when you have like list that no one is running. Okay, and okay, so let's start it again, and let's pm2, and there is this like monitor the processes. So if you like to monitor this thing, different processes, is it, so it is causing the error because it's trying to connect to MongoDB. Okay, and it's like the memory it's taking, and okay, and yeah, that's it. Anything module generate? There are some advanced things like, you can publish the whole module system once once you are through with your release and everything is working, you can just publish the whole code and it will have that. And it is like, compatible with the almost all the major frameworks in the Node.js world. The sales, or because internally it just all of these are, the abstraction, the factor abstraction over the native HTTP node module. So it directly, kind of speaks with that. Uh, I think we covered the Koa, we covered process manager, and this is for the next. I might not be covering this in the May. So yeah, that's it. Thank you for listening. If you have any questions about anything we discussed during the session, we can go through.
What's your experience with deciding architecture based on the structure of teams or the distribution of teams? So, will you give more preference to the architecture, or will you redesign your architecture so that distributed teams?
The first preference always goes to the architecture because that is the actual problem we are trying to solve. And I mean, you cannot make an excuse that just because my team members are distributed or they have a certain kind of expertise, we will apply for a very low level architecture or any other alternative architecture which suits that. First, it has to come with the problem statement, and then it's for the team. So that is why. So these are the things you should first have it. And when I say that, it's a more objective thing because uh, these are the things you on a iteration basis you have to communicate through your client only. The clients are not that dumb. I mean, they can see like these are the things which matters, and how do I see it? Where do I see it? Does it have that this thing? And we have a necessary evils called as testers in our team to make sure that we have all the business requirements. Testers. They play like a so they will have a scrutiny intent for every other thing, like why is that way, that way. I'm not able to test it. Um, so if I like to test something, for example, the whole process of it, and it requires sending so many emails and SMSs, and it is getting executed very frequent number of times in the day, why can't you have the very modular structure where you can actually mock it? I mean, this is one of the examples. There could be many such cases.
And then you give importance to using collecting data first and then basing decisions on that.
Sorry.
Like you follow a practice where you always look at the data first and then decide based on that.
Yes, yeah. So that will be my because maybe because my experience that way, because I always value and always see the how the data is being modeled, what is the frequency of it, the data growth. So these two factors, right? The transaction capability, users growth, and data growth. These three factors which I comes to my mind as a first thing. Okay, I didn't get a chance to.
There are some apps half an hour.
About half an hour. So we have enough time for questions. Good. or maybe half an hour. Maybe I can cover one more topic there. So how do you? So all of you are working in a JavaScript, right? So what kind of architecture do you follow, or what's your sheer understanding of it? Could you explain, like in a brief manner, maybe?
Right now we are working with JavaScript as a standalone application which uses the web technology.
Standard application which uses.
Web technology.
Okay.
So we are creating like widgets and
So you produce the widgets which runs in the browser stream, right?
not completely browser. Our our app. It's a standalone application.
So widgets as in the UI widgets, or
Widgets can be a single application, individual application.
you mean a component? Okay.
Yeah,
Okay.
component.
Okay.
So we are using the JavaScript.
Okay.
So I was going to ask that is there any specific architecture for like we use for the web application? Like for the standalone applications we use the web technology like auto application.
Like what?
Auto development.
Atom development.
Yeah.
Atom is what?
It's editor, but it is a standalone application which uses the technology. You can create a standalone application.
Oh, okay,
Yeah,
okay, okay.
That kind of
Exactly,
application.
okay.
Yeah. So is there any kind of architecture design for that for application?
Yeah,
like that?
okay, so what you're asking is me the next point which I'm going to cover.
Yeah, yeah, I think just like hybrid apps.
Sorry. So there are, so this, anyway, this slide is actually incomplete because it only covers the Cordova apps. There are, so you can write the normal HTML, CSS, JS to produce, as you said, standard application, but code remains the same. But the way you achieve the execution file of it by using the something called as electron. So Visual Code, Studio Code, Atom, these all, even Slack, the desktop Slack is built upon electron. Okay, and there are some. So if you like to ship it as a the APK file or iOS Windows, which can be installed on the mobile devices, you have Cordova. Okay, so the difference is really taking more the emphasis of that particular system and the desktop and capability of it, which Electron is more helpful at. Because so on a mobile device, when you so all of this runs in a web view, which is nothing but a basic Chrome browser engine, which and only one process is wait for. But if you use Electron and all, so for example, if you're doing Atom Editor, many number of tabs are open, right? Many of the things plugins are taking care of, refer and all sort of things. So it requires multiple processors on the operating system to participate in order to achieve that behavior. But even if you're doing a simple search over all the project, a stream search for it, right? So Electron kind of follows the Chrome model, like number of tabs which you have in the Chrome that respond to different Chrome helper processes. If you go to Activity Monitor or Process Manager, depending on what system you are making use of, and through those processes it achieves that behavior. It kind of evenly distribute the computation and I/O tasks. So yes. And for example, this is Cordova app. The Slack version which you get installed in the mobile, it's built using. So there is another alternative to Cordova is by Microsoft. It's called as Xamarin. So Slack is built on top of that. The desktop is built on top of Electron. And this is very favor modular architecture in the sense that only the runtime is going to change, and runtime updates are like they are making very good enhancement in terms of garbage collection and the speed of the JavaScript engine, rendering. So you built on top of Electron, or because Node.js doesn't provide you any desktop UI library in the SDK. Yeah, it's like
The
you.
product is already built, so we create widgets into it, which can run into that specific product.
Okay. Hmm. So do you test drive your application?
Just we test unit test, just unit test with
QA unit.
yeah,
QA unit is okay. Q unit.
yeah, we test our code with
And is it a library? Is it
yes, it's a jQuery library.
Oh, jQuery library. Okay. Okay.
So, what is the product you guys work
Uh, it's a client side thing. It's basically like Electron only.
on? Okay.
A standalone application
Okay.
where some applications run. Like there's thing like a widget.
Okay.
So our widget can be anything of Facebook plugin or Facebook or a Twitter or anything or a custom maybe.
So you can install your application as a desktop application.
Yes. They are selling that product as well. Yeah. Like browser.
That is almost like a Slack. Slack already have that different widgets and which you integrate like plugins and all. At least the plugin wise, not the domain specific, but the plugin wise. So if I already have a particular version of your software, and if I need a new widget, so do I? Is there a your store like a thing that?
Yeah, then this all everything and it will
Oh, you can install from
yes,
it.
install.
Okay. So what exactly that application does? I mean, where does?
It's a strictly based application they have created. Exactly, we don't know the infrastructure of that. We just create the widgets into it. We have got work of that. Creating widgets.
Qt as in the UI on Linux with
Yeah,
the
the
Qt.
Qt framework. They
Okay.
have built with that.
Okay.
It's what that is.
Yeah, but okay. So,
Maybe they're using internally Qt, the web view,
mm-hmm.
Qt web, which run our widgets.
Oh, Qt. So it also comes with the web view. So okay. Mhm.
See.
But I'm not sure about. I mean, how many different features it provides Qt.
Yeah, right now they're thinking of upgrading that web view thing, V8 and latest web kit engines.
Yeah,
Because
FQT.
it has some limitations.
Yeah. Cool.
Qt is very useful. I know for like web views, but for native views,
Yeah.
it's very good. So I used to contribute to Clementine, the music player, which was written in C++.
Clementine.
CLE,
Huh?
Clementine.
SEL.
CLE, Clementine Media.
Okay. Media player. Okay. Written in C++. Pavel Bar.
So C++ on its own is called the Qt very nice abstractions over network, working with the networks, working with the audio devices.
Okay. And that's so where is okay. Apple's WebKit. And version of Google is Google's Blink. Okay. So it's still Apple WebKit. But can you update the that Qt WebKit in a given version of Qt separately? No. Why? Yeah. Okay. Okay. Nice to know.
We just know that internally it uses Qt WebKit, which runs our JavaScript and HTML code.
Hmm.
Does it provide some APIs for accessing native app desktop features or something?
Not completely native. So for movement and all those things, they have provided their products API.
Sorry, for
Their internal products API they have created, and they are providing to access with JavaScript. From JavaScript, we can access their native code.
oh, okay. So like, let's say if you want to display a notification on a device
Yeah.
or something.
Guys on the call, sorry, I forgot about you. Any questions? I'll take that as a no.
You just mentioned regarding CQRS, right?
CQRS, yeah.
So actually it comes with that event source architecture.
Event sourcing architecture, yeah.
Can you just tell a bit about that? I just read it somewhere.
Hmm.
So whether we follow it somewhere, we might have followed event source architecture, or if I have never seen any such real project
Okay.
that follows it.
But you so you segregate. Okay, let me at least tell you and give you the idea like how it looks like at the level. What should
like event store and all.
uh, yeah. So this is the simplest one.
Right.
The simplest.
So I figured like
So you have may not be UI, but actually the business, but your style of querying is different from the commands. Okay, so what you do is uh, you separate out how you're gonna read it and how you're gonna update it, and this may not be actually it also involves the what you say the message queue. I'm not able to find the read model. Just to, if I could find the event handlers command. Yeah, so okay. So so this is the one. So from ORM or maybe data access layer, you query in a different way and you command in a different way. Okay. Now you could achieve the query and command to the same database or a different database depending upon that depends upon how you model your architecture, the persistent architecture, depending upon the load and various growth factor. But what you do is, suppose two people are trying to shop the same item on the e-commerce site, right? So what should happen? So it should query the actual database that is it available or not. Okay, it's available for both of them initially. That is why they are able to proceed with the checkout. Okay, but one of them um, is going to have the checkout earlier, even in the milliseconds, right? So how to, you know, deal with that situation? So what you do is when you check out, you first always make that, is it being available already? There are two calls when you actually show the search results on the e-commerce page and when you actually check out. Even when you check out, you read for it. Is it already there or not? Okay, and then what you do is, if it is not already there, so the same thing which I explained in the domain-driven design, you have all the aggregates. The root entity is the product, but orders and whether it's present in inventory or not, and all those things. So once you get it, you fire the command query. Okay, and there are different event handlers. You fire the command query, you put it on maybe a distributed queue. Okay, and there are different event handlers to execute that command, and those event handler will actually make the integration with your main persistent logic. Okay, now so there are different ways. Can you make the query on the database, or can you also make the query on database and as well as the distributed queue? You can also make it on a distributed queue yourself, right? Whether it's in a queue or not. So depending upon what granularity, time granularity you need it, you make use of that query pattern. Okay. Now, so for example, there are many orders, through Amazon or Flipkart. What they do is they let out into the Cassandra. At least Flipkart does it. Okay. Cassandra is like really, really good at replication and really, really good at writing, but it's not so good at reading. So that is why it's called as eventual consistent database. Okay, it can handle many of. So once you write it, so what you're writing here is the event. Event has occurred. Yeah.
From that event I am getting the state.
Yeah. And eventual consistency also depends upon how desperately your domain needs it. Right? Because again, going back to this code, like we need to be optimistic about everything, like and that's the scenario going to happen. But is it really going to happen in production? So instead of just doing a premature decision of transaction on each and everything, okay, maybe when it actually kind of needed, and when you kind of release your product, you went through the various different testing, UAT testing, and all sorts of things. Even if you cannot find in there, then it may not be useful. And what might happen? Even if you like to check out, the maximum it can happen that so Flipkart conduct like big billion days or something like that where you check out. So this is like a queue the request, and then after a day or some hours they let you know that no, there were many requests in the queue. We served them, and it exhausted our inventory items. So we cannot give you that, and we'll refund you the money. So it also depends upon the domain. Like not all of the things are achievable.
I think they used Elixir to get the scaling problems.
So okay, yeah. So that is because of Erlang VM instead of saying that Phoenix, because so we have a solution for. I mean, we have different minds in IT. So some provide like a complete solution at product level, maybe built in with the technology. Some people go vary at the language level. So Erlang VM comes with its own distributed database and the RPC mechanism between that. So if you use Erlang VM, there is no need for it. Yeah, and the process life cycle is really good. Okay, cool. We'll stop here then. Thank you guys for joining.